All right, this is for Algebra 112, and we are writing and graphing compound inequalities. And we're going to look at writing compound inequalities, and then how do I solve and graph compound inequalities. Now, I will tell you the solving, that will be done. I will write some sample problems because we realize the work is not included in your packet. So, here we go. When we have what we call compound inequalities, and we have the word and, inequalities, the and statement and inequalities have a tendency to graph together. And so what we're looking for, what this means is if x is greater than or equal to -6 and x is less than or equal to 1. Well, if x is greater than or equal to -6, that would be a closed circle, and it'd be going this way. And then it would say, and x is less than or equal to 1, and that would stop right there. What you're saying on an and statement is you're looking for all the numbers that are between -6 and 1, and that's it. So this is what we call a compound inequality. Okay? Then on this one, the or. If it's an or statement, we would separate those. So that means if x is less than or equal to -2, which that would be a closed circle, and all the numbers less than -2, or all the numbers greater than 3. That's an open circle because it's not equal to. So we're looking for, on the or statements, they would be separate graphs and they would be going opposite directions. So for the word and here, a lot of times we'll rewrite that equation or that inequality. So because the solution to an and inequality falls between two endpoints, they are frequently written as one in more of a condensed form. So for example, if we have x is less than 5 and x is greater than 1, we're saying all the numbers between 1 and 5. And since there's so many numbers, or not just whole numbers, but there's so many, we can actually rewrite it this way. We will start with our the least number first. So the numbers are between 1 and 5. So we're saying 1 is less than x, which is less than 5. This is a compound inequality, and then that would then match with a graph, and you'd be able to quickly graph it. So we're going to work on that right now. So you have the number x. Sorry, I have to move something out of my way here. Okay. You have the number x greater than, what's that say? -8 and less than or equal to 4. Well, this is the word and less than or equal to 4, not this word or. So this is and statement. We're going to be writing it like this. So we have the number x greater than -8. So that means -8 is our lowest number. X is greater than that. So that means -8 is less than that. And less than or equal to 4. So it would look like that. Put it in numerical order, least to greatest. And if you do that, and if it's an and statement, your sign should be facing the same direction. So we have -8. We're just going to put -8, and we're going to put 4. Now that's an open circle. That's a closed circle. And then that connects. Okay. If it's an and statement, it's going to have just a range of numbers, that two endpoints, and connecting in between. This one, a number y is at most 0 or at least 2. So the number y is at most 0. That means it has 0 is the max, so it can be less than or equal to 0. Or y is at least 2. That means it's going to be greater than or equal to 2. When it's an or statement, remember, you're going to have two separate inequalities. And if you do it from the lowest one first and then the greatest one second here, your arrows should be pointing, your inequality sign should be pointing opposite directions. So y is 0 and y is 2. So closed circle, all the numbers less than 0. Where is my 2? It should be there. Sorry. Or all the numbers equal to 2 or above. Okay. All right, this one, I'm going to zoom in here a little bit. A number D is more than 0 and less than 10. So a number D is more than 0 and less than 10. So it's a compound inequality. So we're going to start with 0. It's more than, so it's not going to be equal to. D less than 10. So we have 0 and 10. I could probably count that out. But open circle, open circle. So and statements, you're going to have a compound inequality with the letter in the middle. Or statements, there's a compound inequality, there's two of them, but you have the letter in both of them, and they're going opposite directions. All right, so on this one, you can pause it and try yourself, and then just check. But you're going to have a number x is less than 6 and greater than 2. I always like to circle or highlight my and or statement. So it's greater than 2 and less than 6. So it's going to be between 2 and 6. And 2, 4, 6. Oh, that's going to be open circle, sorry, because it didn't equal 2. That should be open. All right, and number m is above 4 or below -1, or, so it's above 4, so m, so I'm going to do this. M is greater than 4 or below -1. So I went ahead and did it this way because then that'll match up with my number line. Even though that was 4 was stated first, I know -1 is lower. So that way my variables are on both sides like this, on the left. And then you're going to have -1, 4, open circle, open circle. Okay? So graphing and or statements, not too difficult. This is just saying all the numbers within that range, like 2.457832. This one is saying that only numbers less than -1 or greater than 4 will work with this. All right, so now let's look at the back page. This says write compound inequalities from a graph. And what this is saying is we're going to write it from a graph now. And this little trick here, not really trick, but it kind of helps you with an and statement. You're going to have your lowest, the left end point is your lowest number. It represents the right, and the R represents the number. And your variable is going to be in the middle. If it's an or statement, you're going to write two different inequalities here. Okay, so write the compound inequality that represents the graph. So this is an and statement because it's talking about everything in between. So we have a -1, it's less than x, which is less than 2. Okay, if it's filled in, make sure it's equal to. Number 2 is also an and statement. So we have 0 is your lowest number. That is filled in, so it's going to be less than or equal to x, and then it goes to less than 3. These are or statements. So we have, I would start with your variable first, start with your variable. And this is going to be less than or equal to -3, or x is greater than 2. Okay, so wherever the number line, wherever the circles are, in which direction they're going, it'll tell you what's happening. So this is another or statement. So x is less than -1, or x is greater than 1. I think that's a 1. No, that's a 2. Sorry. That's a 2. It's hard to see about the side. Okay, so then going through these 4 and practicing, this is an or. What type of line is that? That's an and, or, and. Okay, so this should be x. If they don't tell you what variable to use, just use x. X is less than 0, or x is greater than or equal to 7. This is an and statement. That means the variable is going to be in the middle. Your lowest number, that's going to be a -9, less than or equal to x, which is less than or equal to 9. Good. This is an or statement. X. Now watch this increments, though. These are going up by 2s. They're going down by 2s. That's -4 and -6. So less than -6. Or x is greater than 8. And then it's an and statement. So -5, less than, there's no equal sign, x, less than or equal to 2. All right, so that is how you can graph the inequalities. We're going to do another video on solving inequalities. So that's your first video. Your second one that you're going to have, get a notebook paper, and we're going to write some problems down on solving inequalities. That'll be the next thing because you're going to have some delta math to do with that one. Okay,